Welcome folks to this demonstration on how to use the functional generative design tool from the 3D Experience platform. For those familiar with SOLIDWORKS, this is similar to topology but connected to the cloud. And here I'm bringing in a SOLIDWORKS native linkage. Now we're just defining the bodies that are going to be bounded. And I'm actually doing a Boolean operation between the imported body and the part body found in there so that we have some bodies to optimize. Next, I'm going to turn on the assistant to create a simulation from this. And the wizard will help us take it through the rest. Now I'm going to add a material first. And here I'm going to use 1020 cold rolled steel. Click the menu, click apply, and we'll select the model to apply that material. Now we're going to set up our design space, and it's picked up our body. And now we're going to define the functional regions here to say which piece of the geometry do we need to preserve, either a volume or a face. In this instance, I'm going to preserve the mating faces. Next, we're going to add our loads and restraints. And we're going to do the maximum case load that's going to act on this section of the model. We're going to define a force of 400 newtons on each of those two holes for a total of 800 newtons. Next, we'll add our restraints. We're going to clamp the two front ends, but the bottom holes are actually a part of a moving hinge. So we are going to switch the restraint to hinge and select those two. Now last, we need to set up our load case scenario because we can combine loads. And we have to tell the software that, hey, we're going to use this load case, this combination of loads and restraints. And now we're going to validate that this setup works by running a static simulation on it with validate setup. I'm doing this locally on my 4 cores, but I could also have run it on the cloud or with credits. And similar to SOLIDWORKS, we get our maximum displacement, Bakovsky stress, and other results from this. And now we can set our optimization target. We're going to maximize the stiffness with 35% of the model, but we could have minimized mass as well, and compute the shape. I did most of this locally, so it took a little bit longer, but you can also run this in the cloud to run it much faster. And now we just press concept shape once we've computed that shape to decide the overall shape that we'd like as the result. Just by sliding the slider back and forth, we can watch it add or remove material. We can switch back to the model. And we can even see the transparent design space around our optimized shape. Then we can create the concept shape and export it out when we're done. Let's take a look at this overall deformed shape. We can save this and export it out when we're done.